All right, good morning, everybody. I'm Chris Ferris, so I do cloud security evangelism. I'm an AWS security hero.
My name's Rich Mogul. I been doing cloud security research for quite a while myself. I'm a security sidekick. That is a height reference, I think.
Yeah, well, and he's in the Amazon AWS Community Builders program.
Yeah. So today what we're going to talk about is security invariants. We're going to give you definitions of security invariants. We're going to walk through, and so we're going to start at that kind of top level of what these are and what their meaning is, but then we're going to dive down, and we've got a wealth of technical examples, show you different kinds of policy examples, and we're going to walk through the major categories of invariants as you can implement them on AWS today.
Yep, and it's a 400 level session, so there will be JSON. Apologies for anybody who's, So when you think about how these all fit into the whole spectrum of security, we're talking about choosing your guardrails. And I like this slide because it kind of really defines different guardrails you can have. The guardrails of IAC scanning are kind of like the rumble strips by the side of the road. They remind you, hey, you're going off the road, but they're going to let you do that. Auto remediation is a little bit more forceful. You can go off the road, but it'll bounce you back. But where we're going to be today is in the service control policies. And those are things that very much will not let you deviate from your security control.
And beyond service control policies, because there's now a lot more options for security invariants, especially over the past 2 weeks.
Yes, actually over the past 48 hours even.
Yeah.
So a security invariant really is a preventative control, and it's called an invariant because it always holds true for your business. And the catch there is always holds true.
One of the things that when Chris and I first started talking on this topic is he actually educated me about, because I was talking about invariants with exceptions, and we're gonna get more into that later. And the concept behind an invariant is it doesn't change. It's a policy you set that is strictly enforced so that anything that might be an exception is built into the invariant. And that was like a real mind shift for me that I got from working with him. Yep. And why these things matter is that and we've written and published our own threat models. Most of the kinds of security incidents you will face are from really common kinds of mistakes. There's not the complex attacks. Those do exist, but that is by far the minority of the kinds of attacks that most organizations, even highly valuable targets, are going to experience. So the idea of an invariant is to reduce the burden on your development teams and on your operations teams. Now, yes, they're not going to love everything about these invariants. You're putting guardrails and you're forcing them to ride between those guardrails. But it's not they did something bad and you detected it and now they have to go fix it. It's about preventing those things from happening in the first place. And it should reduce the security burden, reduce the kinds and the numbers of incidents that you're going to be dealing with.
Yep. So, and these all fit within a security spectrum, right? So I like this because it really, you want to educate and empower your developers. That's the first step that's going to stop a security issue from happening. Architectural design reviews, partnering with your developer teams to say, hey, you shouldn't use a public bucket, use CloudFront origin access identities. And then we get into the more technical controls like IAC scanning, service control policies, auto remediation, which happens sort of after things have gone into production. And then, finally, you end up in that CSPM vulnerability management, what I call spreadsheet hell.
One of the things where the reason invariants might not be a concept you're really familiar with, particularly if you come from traditional infrastructure, is that we couldn't do them. Like, you don't have the ability to set centralized policies that are consistently enforced in a data center because we're dealing with a hodgepodge of technologies. Not because we've done anything wrong, that's just the nature. You have to build the networks, you have to build the servers. There's no single control plane for where we're operating. But cloud changes that fundamentally. And over time, Amazon and predominantly AWS has evolved to give us these centralized policy capabilities that can be enforced consistently across these kinds of environments. ideally to get us out of that spreadsheet hell on the other side where you're just fighting and patching and fixing and detecting and running around from the outside. Now security can actually kind of layer in and enforce things at that top level. Now, to do this well, you have to have good invariants, because anytime that you're putting blockers, and let's be honest, these are blockers. Like you guys heard for security, we talk about CIA, confidentiality, integrity, and availability. A friend of mine, Gunnar Peterson, he's like, that's a lie, because we don't do availability, because every security control is a denial of service attack against your own employees from a certain perspective. So the idea of the invariance is you need to be careful, because you don't want to break the ability of the business to do what it needs to do, but you're giving, ideally, the developers this road that they can run down very, very quickly, and within those guidelines, make it more of a frictionless experience. Yep. And so to do this, they have to be specific, enforceable, realistic, and avoid exceptions, which is the piece that I largely got from Chris. Specific is in, you really got to narrow things down, and we're going to show you some detailed examples of these, the principles, the actions. What is it you're actually protecting, or what is that guardrail going to be? It has to be enforceable, and you have to have that policy enforcement capability. So for a while, it was largely service control policies and permissions boundaries and a little bit of block public access. And now we have resource control policies, and we have the declarative policies, the other one. So we're going to go through that. They also need to be realistic. I have worked in some of the advisory stuff I've done with organizations that set very unrealistic rules. I hate to say it, largely it's usually done at the firewall, where you actually are blocking the ability of people to get things done that they really need to get done for their jobs. So the way you write the invariants has to account for that. And ideally, and again, I keep mentioning this because it was like a big eye-opener for me, exceptions should be built in. You shouldn't have to be writing business risk of acceptance forms and everything else for things that are invariants. Ideally, the invariant applies very consistently across your environment. Because
I want to say that you can't actually bend the invariant. When we build these invariants, they're there. They are these concrete barriers that are keeping you on the road. And it takes significant effort and introduces significant risk when you have one of those exceptions.
Now, as a former firefighter and a current paramedic, I know how to get, I've seen people go through those barriers. It doesn't end well at all. Yeah.
And so, right, a security invariant is always true. So you can't write a variant that says no one can create a VPC.
I mean, you could.
You could, but then you'd have no network, right? So what you want to be able to say is, only my network engineering team can create a VPC. And this is where you bring in that concept of built-in exception. And we'll show you how this gets implemented. But step one of writing the or coming up with the invariance is writing it out in English. So some examples. Only the network engineering team can create a VPC, alter route tables, or attach an internet gateway. Very explicitly excluded from that is security groups. Builders can go ahead and define their own security groups, but they can't alter the route tables. They can't attach transit gateways. They can't put something on the internet. VPC block public access introduces some new capabilities here, but the invariant is still in English. How you implement it could be service control policies, could be a declarative policy. Another example, only the security and privacy team may make an S3 bucket public. Now you want to do that because, you want to understand what that data classification is. Maybe you don't want to have a lot of public buckets in your environment because generally they're bad practice and they make auditors squeamish. So you want to reduce that number. But you will have public buckets in your environment, full stop. So you can't say there are no public buckets. Anybody making that kind of declarative statement is not facing reality. Another one that's less security, but it's more FinOps related, is only procurement can subscribe or accept an offer in AWS Marketplace. And you kind of want this one because you want to go through a third-party risk review before you go and sign up for any of these big logos out here. Maybe you want to have an enterprise standard around, we are using this version of MQ, and so if a developer joins the company and is like, oh, I used Rabbit at the last place, I'm going to use it here, they can't just go and sign up for a 6-figure contract. Final one that I really like is only my central cloud engineering team can enable a new opt-in region. This one is super important because when you add a new region, you got to make sure guard duty is enabled. May see if you're using it, security hub. There's a whole slew of things that need to be turned on if one developer somewhere just wants to start doing things in Milan. There needs to be coordination in your environment. So by making it only the cloud engineering team that can opt in a region, they can opt in the region in the account that needs to work in Milan, and in your security tools account, and in your organizational management account, and in your infrastructure account if networking connections need to happen. So that forces the coordination to happen.
Notice that these are not the be-all, end-all of security. We're not trying to hit every little use case, every little nuance, all the ways. It really is, the invariance is about setting that baseline level. The objective is to reduce the security burden and provide a certain degree of consistency. It's not the solution to all of your security problems. All of our other tooling, all of our other nuance and approaches still come into play.
Yeah. So this is part of making the secure way, the easy way, the same way. So our options for enforcing invariance pretty much doubled over the last 2 weeks.
Literally doubled over the last 2 weeks.
We used to only have service control policies. Now we have resource control policies. We always had IAM permission policies, or at least since 2011 or whenever when they created IAM. Permission boundaries. And now we had some declarative controls like block public access for S3 and EBS. Now we have declarative policies which can enforce that across an organization. And then I always kind of add auto remediation as one of the invariants, because some invariants I'm going to implement through service control policies. Some invariants I can't. And so I have to move them to the after the fact, after it's deployed, something detects the misconfiguration and immediately resolves it. And I kind of have 3 laws around how auto remediation should work. One, a bot should never touch or harm production data or cause production data to come to harm. It must act quickly so that that misconfiguration does not become structural. You're not relying on that public bucket being public for your availability. And finally, a bot has to tell a carbon-based life form that it did something. And so, yes, with
by carbon-based life form, he does not mean my cat.
No.
We're not convinced my cat's a carbon-based life form. The jury is out on the whole.
But we are convinced it's a threat actor.
Yeah, he's a threat actor. We put him in a threat model.
So service control policies, they're managed by AWS organizations. You put them in the organizational management account, aka the payer. And they'll define the maximum permissions of the account, including the root user. So this is prior to the new introduction of centralized root management. This was the way to control root usage without actually having to log into all 1,000 of your accounts and enable MFA. The important point to a service control policy is it applies to the identities in your organization.
We're going to go through the policy evaluation logic. Some of you know this, some of you don't know this in a few more slides, but that becomes really important, that point of how SCPs apply to identities, because these invariants, when we first put this presentation together, almost exclusively applied at the identity layer, and now they apply at the identity layer, at the resource layer, which also is an IAM based, but also at a few other layers, and we're going to walk through those.
Yep. So, service control policies apply to the identities that belong to you in your organization. Resource control policies apply to all identities in AWS, whether they're in your organization, a partner organization, a threat actor organization. They apply to every AWS customer against the resources in your account, the specific ones that are currently supported, which is S3, STS IAM. AWS says it's STS, and that's technically true, but really it's a resource control policy on the assume role trust policy of your IAM roles. SQS and Secrets Manager are the other two.
I personally was surprised that they included STS in the resource control policies, but it was like, I'm very happy because that's one of the better use cases for RCPs, as opposed to some of the use cases which, well, we'll get to.
Yeah. There's
some holes.
Yeah. And then there's declarative policy. So we've always had things like, well, we haven't always had things like, but for a while we've had things like S3 block public access, or EBS snapshot block public access, IMDSv2 enforcement. So what declarative policies do, and these were literally released on Sunday night, what declarative policies do is, and they don't look like IAM policies at all. They actually look more like AWS backup policies. So it's a completely different structure in AWS organizations for what the declarative policies look like. They are enforced at the service level. This is enforcement that happens outside of IAM. And currently they support most of the things that that the current declarative controls support. So you can block public EBS snapshots across your org. You can block public AMIs across your organization. You can enforce VPC block public access in your organization, although we have not yet played with that. I imagine that there are a lot of weird edge cases there. And probably one of the more useful ones is you can now actually enforce IMDSv2 across your entire organization.
The way to think about the mixture of these is, as we mentioned, the service control policies apply straight at that IAM level on users and roles. Don't use users, by the way. We all know this, right? You don't have IAM users anymore? Good. Roles in your environment, and that includes cross-account roles that you allow into your environment. So it's operating at that API call level. Then you've got your resource control policies, which are about restricting or managing access to resources, and that's going to be enforced more at that resource level. There's a weirdness at which level, which we just learned about yesterday, they get enforced at. It happens at the org level, but it affects resources, like a resource-based policy, like a bucket policy, similar where it applies at that level. Then the declarative policies, my mental model to think about these, since Sunday night, is it's consistently enforcing a configuration within the control plane. So it's not like a JSON policy that's interpreted with a batch of other JSON policies as part of the policy evaluation logic. It's just, thou shalt always turn this on in this way.
Yeah, and the way the declarative controls, which are managed by the declarative policies, are actually implemented is at the service level, regardless of whether you have permissions or not. It's just outside of IAM.
Oh, and remember, all of these things are, when we say they're enforced within AWS organizations, which they're
managed, yeah.
Yeah, and they're also manageable at OU and account levels typically.
Yeah.
So it's not like you have to write the invariant to work the same across everything. You have different invariants for development and prod, and that's super common.
Yeah. So a declarative policy invariant example for, say, AMIs. You might have a company where part of your business is to ship AMIs. You would create an account that is your AMI hosting account, and you would put that in a separate OU, public AMI OU, and you would apply the declarative policies to all of your build, test, production, whatever else, and it would just be this one account where you share out your AMIs that would not be subject to the declarative policy, and so only accounts in the public sharing organizational unit are allowed to have public AMIs. And that's how you would write the invariant in plain language, which would then be implemented through declarative policies in AWS orgs. All right, so to get started here, a couple things you need. You need AWS organizations. Hopefully everybody is doing this. Please, 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 whatever you do not take your existing account where you're running production and because you have your your enterprise discount or credits or whatever, and go turn on organizations. Create a brand new account.
Who would ever do that?
Create a brand new account. And then move your production accounts under this brand new account. You don't want to run workloads in your AWS organization account. Part of the reason is because that account now has the ability to assume root into all of the child accounts. So there's a privilege escalation path, small one, but there is one. You want to turn on AWS Identity Center. Again, IAM users are bad, please don't use them. Although even that is IAM users are bad, please don't use them, not there shall be no IAM users. You won't get away with that. I would highly recommend tying your Identity Center into whatever your corporate onboarding, offboarding thing is. And then you really want to manage this all through infrastructure as code. Terraform right now does support service control policies and resource control policies. I haven't looked since I've been here whether declarative policies and some other things are there, but they will shortly.
And CloudFormation. Some of us still use it.
I'm on stage at an AWS event, I'll keep my mouth shut.
Okay.
But the last point on the infrastructure as code is you want your builders to know what the rules are, and you want them to be able to see these rules. So this is one of those, infrastructure as code GitHub repo or Git repos that I would want to be read-only to the entire organization. So they have an idea of these are the rules. Oh, this is the service control policy. This is the invariant that I'm hitting. How do I work around the invariant? Oh, I need a VPC. Let me call up the network team.
So this is where the policy evaluation logic starts becoming important and being able to understand it. Now, I don't recommend you take a picture of this slide because this is outdated as of about a week or so ago. The problem is the new version, which is posted up on in the documentation on AWS, can't fit on a screen very well. So we did decide to stick with the current version, and I'll talk through some of the differences as we go through this. And the policy evaluation logic is in what order are these rules evaluated as you go through. And this is why knowing where resource control policies fit in versus resource-based policies actually matters. So for our purposes, and using Amazon's terminology, which is the same terminology I use, we have organizations-based policies. So those are policies like service control policies and resource control policies and
declarative policies.
Declarative, the one that begins with D, policies.
But those don't actually go through this evaluation because
no, they're outside of this, but those live at the organization level and can apply throughout the hierarchy. That is different than identity-based policies, which are attached to roles and users within your own account. So those operate at that level of that identity, and those are at the per account level. They are not, there's no such thing as an identity-based policy at the org level. The closest you get is a service control policy. And then we have resource-based policies, which are policies associated with an individual resource. Now, why do we need those? Because you can take an S3 bucket and you can share it to outside IP addresses. There's no API calls involved with that. Now, and what we're going to focus on is largely the organization-based policies and one aspect of identity-based policies called permission boundaries, now that we're getting into the more technical section for the back half of this presentation. Because we didn't have resource control policies in this particular diagram, so you know where they operate, the new policy evaluation logic is any call that goes to go to a resource is evaluated at the resource control policy at the org level before any of the other policies. So if there's And with all of these, you have to have an allow statement at every level and no explicit denies. So this is where understanding an implicit versus an explicit deny becomes important. As you'll see when we write the policies that we're going to get into, everything in AWS has an implicit deny. If I turn on service control policies and I do not put in an allow all, instantly I break my entire organization. That's why Amazon does that by default, because you have no permissions. So the moment you turn those on, there's an implicit deny. Then there's explicit allow, so you add your allow statements to build out what somebody is allowed to do. And then you have your explicit denies, which says, always deny this. So there's an interaction among those, and we'll get a little more into this as we go along, but when you're going into a resource, as you might imagine, sometimes access to those resources doesn't have an API call. You're going to an S3 bucket over the internet. So that has to be evaluated first. Then the IAM logic is going to go ahead and kick in underneath that piece of it. You have to have allow statements at every level and no explicit denies. Where the difference is with resources is direct access to a resource won't go through the IAM unless it's an IAM entity that's in your environment, in your account, in your organization. So that's just that one little difference that gets highlighted in this slide here. So the big part about this, and what I meant by these implicit and explicits, is the invariant tools we're talking about. Service control policies, resource control policies, and declarative policies, and permissions boundaries, which we haven't gotten to, but we will. Those don't grant you any permissions. Those are statements of the maximum amount of permissions. So if I write a resource
of a maximum amount of permissions that you could have.
You could have, yeah. So if I write a resource control policy that says public is allowed, it doesn't make things public.
Yeah.
Those things are only public if the resource-based policy also says public is allowed. That's why these guardrails, that's why it's the Jersey barriers that he was talking about.
Yep. And so there are some other ways to do invariants. And again, this was, when we first put these together, we were like leveraging service control policies together with declarative controls so that we turn on the declarative control and then we prevent anybody from turning it off. The declarative policies give us a lot more flexibility in this. But again, we talked about declarative controls being block public access for EBS snapshots in S3, default EBS encryption, force enabling version 2 of the instance metadata service. The other control that's available to you is what's organizational access, AWS Organizations Delegated Admin. And that is a capability that we'll talk about in a minute. So like block public access basically kind of sits at the service plane and can manage versus ACLs and policies, but the service is enforcing that, not necessarily the IAM piece.
Yeah, we get so wrapped up with IAM policies and resource-based policies. Sometimes there's just a button you can click that says, don't let this happen. And that's what those declaratives are.
So delegated admin. Delegated admin is very much a capability you want to use in your invariants. It allows you to say, this AWS account and only this AWS account can manage guard duty in your organization. And suddenly, no matter how compromised one of your workload accounts becomes, a threat actor cannot turn off guard duty. A threat actor cannot turn off CloudTrail. Because of the delegated admin features, they would have to compromise the security account to do that. So you've taken all your security controls, you've put them in an account that hopefully only security has access to, you've limited the blast radius and the access radius to turning those things off, and you've built a invariant. Only the security team may enable or disable guard duty. And because service control policies apply to child accounts only, you can also put a service control policy in that says security can't turn off guard duty, unless the cloud management team who manages the organizations also concurs.
I mean, I love these. The first one of these I hated I loved it in terms of as a security professional when we had the ability to do an organization's cloud trail and then designate that to a security audit account. As somebody who teaches incident response, it really messed up my classes because I wasn't able to turn off CloudTrail anymore and annoy the students.
Yep. So, how to write a good invariant? You really want to start thinking about the personas that are involved. We said only the cloud networking team can create a VPC. So there's your persona. You've got the cloud networking team. Only the security team can turn off guard duty. So you have the security team. Using these roles, these personas that you'll define as roles in AWS Identity Center, that's part of getting started. I typically say turn on block public access in all accounts at birth. With EBS block public access, this is a regional thing. You need to do it in every region. Enforce it at account creation. And then again, delegated admin for everything that you use.
And so if we look at what are the components of a service control policy, they're like any other, it uses the IAM policy language. Typically, in most cases, you're going to have allow alls, and you're going to focus more on your denies. It's very hard to do the allow listing versus the block listing when you're actually building these things out. Some people do it at very narrow cases, but it is really difficult. And so it's going to be like deny the resource when you're able to specify that. Service control policies do support that. And then what do you want to stop? And then the conditions. And the conditions is where the magic occurs.
Yep. So we're about halfway in and you're getting your first piece of JSON. So here's an invariant that I use that basically says you can only log in as the root user if you're on my corporate network. And this one is useful because there are occasions when you need to do something as root. Whether it's 2 weeks ago before centralized root management or today, this service control policy still applies. I need to fix a bucket policy because I'm in an outage situation. I don't want to have to drive into an office, go find a MFA token that's in a safe, something along those lines. We need to log in as root and we need to be able to log in as root quickly. So this basically says all root activities must come from either of these two IP address CIDRs. So again, it starts with an explicit deny on all actions if the principal ARN is the root user. And we can use an asterisk here in the condition. We couldn't do that in the principal, but we could do that in the condition. So if the principal ARN is in fact root, then the deny happens. Unless, of course, not IP address, you're coming from one of these IP addresses. So now with this, if you're at 54, 55, 54, 53, 52, you can log in as root, you can reset a bucket policy, you can close an account, you can change an account name, whatever else. Threat actor anywhere else cannot do that, even if they did have access to the root email to be able to do a password reset and everything else.
One point about invariants in particular is, and you see it in Chris's here, so if you weren't aware, because we know not everybody writes control policies as much as we do, or IAM policies, conditions are and, it's an implicit and. So this and this and this. Because of that, we have to have a lot of double negatives in how we do things. So deny unless is incredibly common as you write these. And like I do a lot of teaching cloud security, and that's usually one of the hardest things to get people to understand is the double negatives when they're, and how to leverage the power of those.
And it gets even more fun when you have like deny, not IP address if exists. Because sometimes you have an IP address and sometimes your call doesn't if it comes from like CloudFormation service.
Yeah, we've got examples of that as we get deeper in.
So building your SCP, define your invariant in plain English or plain language. You need to determine the actions that are going to happen, like create EC2 create VPC. Determine the resources. Here's where you can build in some flexibility. Maybe I want to have a bucket naming scheme that says public dash whatever. Those buckets can be public. And so now it's very clear, if you're looking at a list of S3 buckets, which ones are public and which ones aren't. Because only buckets that start with the word public are allowed to be public. If you have a service control policy, determine if any of the principles apply. But really, it comes down to the conditions and the exceptions. So again, defining it in plain language, only the security privacy team can make an S3 bucket public. Specific around make S3 bucket public. Enforceable, we're going to use S3 block public access in conjunction with a service control policy. It's realistic, right? Teams can create a bucket if they need to. They just need to go through security and privacy to ensure that, all the compliance checkbox, the risk has been reduced, accepted, mitigated. And again, it avoids exceptions. There's no, we have to go turn off the service control policy to create a bucket. We already know who is allowed to create the bucket. It goes through the security team. They do that action. So in this example, and again, this is a kind of pre-declarative policies example, the three actions that we want to prevent a user from doing are putting account block public access.
Just so you know, that doesn't mean put means you're making the change. It doesn't mean you're turning it on.
Yes.
It could be you're also turning it off.
Correct. Put public access or for access points, and then you can do block public access at the account level and at the bucket level. So you need to capture both of those conditions. Now, we said earlier, enable block public access on all accounts at account creation. So in theory, at account creation, something has gone through, set all these things up. So what we're doing here is we're denying anybody's ability to change those settings. That's the invariant. The resource, in this case, everything. And then again, we talked about personas with Identity Center. The two personas that are allowed to do this, again, it's condition string not like, so we're denying, unless you're one of these two roles, the ability to do those actions.
Where you're going to spend a lot of time and what's really going to help your skills in terms of writing these is understanding the global condition context keys. So these are the conditions that are supported within service control policies, and in many cases also within some of the other kinds of policies.
With any kind of IAM policy, but yeah.
Yeah, at a high level, as opposed to services may also have their service level condition context keys. So these are the global ones that are the most widely supported.
Yep.
There are going to be some limits as we run into. And the ones that we tend to use more are highlighted on this slide. I'm not going to read through all of these obviously, but the big ones is like principal org ID. Did this come from a user or a role from within my organization? Is that resource in my organization a resource org ID? Was the request called via another service? There's forward access sessions is the term for, I did know about it before we went to yesterday's talk, but if you go see Dan Peebles and Matt Luttrell's talk on identity management, and I think they're doing it again, there's times where you're having an Amazon service do something to another Amazon service on your behalf. Think about the simplest being if you use a CloudFormation. The CloudFormation service is making all those changes, but it's doing so under your permissions. Yep. There's actually ways that they've added context keys, so you can actually say that CloudFormation can only act on behalf of, say, people on the infrastructure team, and that would be an invariant you might want to go ahead and write.
Yeah, the concept of forward access sessions, think about you ask an S3 service for an object, but the object is encrypted with KMS CMK. S3 has to go ask for permission to decrypt, and that's sort of the second piece of it. It was the day in a life of an identity policy or an IAM policy that is the Dan Peebles, Matt Luttrell talk. So another service control policy might be, I don't want any public lambdas in my environment. So again, we're going to do a deny on all the condition here is, or the action here is add permission, but we actually have the option of a service condition key called Lambda Principal, and we're just looking for the one that says any AWS customer. So that's the example on the left, and then the example on the right is, again, a different condition key, Lambda function URL auth type, IAM. And again, this is one of those double negatives. You're creating a Lambda function, but you're going to deny it if the string is not IAM. So you're forcing all function URLs to use IAM authentication.
So then we get to permission boundaries. Permission boundaries confuses a lot of people more than these other types of invariants we're talking about. They still confuse Chris. I've been working on it for quite a while, and yet last night or the night before, he's like, I still don't get these things.
Yeah, no, anyway.
We were out at dinner. So a permission boundary does not operate at the organization level. It's a managed policy, operates in an account. You can also apply them with IAM Identity Center, which gives you a little bit of broader. And it's a managed identity that is, the use case for a permission boundary is, there's different ways you can use it, but the main use case is you give somebody the ability to manage some parts of IAM, but you don't want them to be able to escalate their own privilege. So an example would be that they were able to add a new, if they have the ability to say, attach a policy to something, and you don't want them to be able to attach that policy to themselves without restriction, because then they could attach an admin policy and they could escalate their privileges. So it is very specifically limited in terms of the practical use I've seen. There's a lot of ways you can use them, but the ones I always see is, I'm letting you administer something in IAM, so you're the team lead and you can add IAM users, but I don't want you to be able to add any permissions for yourself. So that's that role. Again, it requires you to have that allow all policy, otherwise you're going to block everything. That confused me. First time I played with these, it was like the day after they were announced, I broke the IAM role that I was playing with because I didn't have that allow all as part of the permission boundary. And then you deny the specific actions. I have seen this one where sometimes you'll see allows, you don't always have that allow all in a permission boundary with the other ones. So this one was basically with IAM Identity Center, making the administrator not be able to modify their own permission set. And this was in a lab that I produced. Again, permission boundary, it's a managed IAM policy. It's within an account. Even if you do with Identity Center, all Identity Center does is it then creates that managed policy in every single account. And then when you attach that to that role or to that IAM user, it defines the maximum things that they're able to do. Really, almost everything else you can handle with a regular identity-based policy. With a permission policy, the permission boundary is best used if somebody is administering some of IAM and you want to limit what they can do.
Yep. Speaking of limits, and this is where in a large organization with lots and lots of different resources, you might not be able to do a clean enumeration. SCPs can only be 5120 bytes, which is an incredibly odd number, and that includes white space. So one of the techniques to get more out of your service control policies is to literally minify them. You can have 5 SCPs per OU level. So the root OU, then the OU itself, and then the account. But you must include the full AWS access policy or some policy that grants permissions at each level. So you can't just throw full AWS access at the root. If you don't attach it at the OU level and you don't attach it at the account level, it doesn't work. Which really means you only get 4 service control policies for every OU. And then there's a limit of 2,000 service control policies per AWS organization.
And I want to, just as a reminder again, because we know not everybody writes all of these things,
Yep.
even though we're at a 400 level, there's all these layers of policies, and that policy evaluation framework basically says, how do all of these things interact? Because for you to touch one thing in one account 30 levels deep in your organization, or I can't remember how far we can nesto use, everything is evaluated. Every service control policy, every resource control policy, every identity-based policy, every resource-based policy, and then any of the declarative controls that might be in place around and those are outside of the policy evaluation framework. Every one of those has to allow it. None of those can have either an implicit or an explicit deny, and explicit denies will override anything else. The trick is with resource policies, resource-based policies, you can kind of skip over some of the implicit denies and ask me afterwards, because I'll get really lost if I try to explain that on stage right now when I have this much
It says right
coffee.
there, you can have up to 5 levels of OUs.
Oh.
It's right in front of you, man.
So, never learned how to read, and some people don't know permissions boundaries, some people don't know how to read slides. That's me.
Yep.
So, this was a bit of an experiment we did where I'm like, hey, one of the things I want to try to do is I have a batch of service control policies that I typically draw from. I actually take a lot of Chris's. There's another friend of ours, Rami McCarthy. He's got a great library. There's a few other places where I tend to pull these from when I have to implement them. But it is hard to write these correctly, and it's also hard to know the impact of your service control policies before you implement them, because you can't test everything. And there's a variety of guidance around making sure you can use Access Analyzer and some other things. So what's playing on the screen here is I went through and hopefully, maybe if I click it one more time, it plays. So I went through and I actually used Bedrock. I set it up with a Bedrock knowledge base to do research, augmented generation. And I loaded up in the RAG all of the service control policies that I liked. And then Chris gave me the challenge of, this is the sentence, so describe what you want and give me the result. And could it write me a valid service control policy? Then the code went and pulled down the account authorization details, which is all of the IAM users, roles, and policies, and then evaluated the service control policy that was generated to determine which users, roles, or policies would potentially be affected by this. So I tried to base it off of a good known set that had some descriptive information within that. And in this case, I was running this in a pretty isolated environment, so it didn't pull up much in terms of what was affected. But and I did a couple of experiments around this. So it was a pretty interesting lesson. And what I learned is a couple of things. One is I used Anthropic. I just have been getting better results out of Claude 3.5 than the other models that I've been using, and I use all of them that I can get my hands on. They're actually not too bad at writing a starting one today without any RAG involved, because I compared this to just writing the base policy to give me a starter. By the way, you cannot do any of this unless you actually understand these policies and how to write them yourself. I use these tools to help speed up my process. I do not use these tools to take over my process. I am by the way, all for the machines taking over and running human society, because we're not doing a very good job of it. We never have. But when it comes to writing these policies, I like to write them myself in the end. And so the next part of this experiment that I haven't done yet is I realize, in most organizations, you will have a library of your service control policies and such that you're going to work with. I should have used the RAG to just pull which one best matched the use case I wanted instead of trying to write it from scratch, because I think that would have given me better results. I just ran out of time to actually get that part of the experiment done before we got here.
Yep. So how do you actually get these deployed? You've got a great service control policy, you've got an invariant, you really want to get it out there. Well, in my experience, guardrails are like nuclear power, one accident and everybody's suddenly against it. So you want to be very careful, very cautious, very deliberate in how you roll out these invariants. AWS doesn't give you the ability really to test these. there's another cloud provider out there who has an audit function in their organizational policies. And you'll see in the logs whether or not something may or may not have actually failed.
Wait, can I take a step back? As Chris is getting into this, understand there's a huge difference between writing and deploying these in a greenfield environment where everything's much easier. Chris is really getting into the fact, because he's had to do this in some gnarly places before, in deploying one of these where stuff's already running, like you can break production workloads.
And I actually think that greenfield environment is a myth. If anybody actually has a greenfield environment, I'd love to talk to you. I would leverage your SIM here. This is a good place to be able to say, okay, who actually has done Lambda add permission? Then have they actually ever done it and looked for that condition key that says I'm applying it to every AWS customer? Okay, somebody did do that once. Let's go have a conversation. Did you mean to do that? Do you do that regularly? This will tell you if you've got a deployment pipeline somewhere that you're going to break when you roll out this invariant. It's very important when you're looking at the CloudTrail events. A lot of the detail is going to be in the request parameters and in the session parameters under the user identity elements. So that will say, oh, it's the networking team. Okay, well then this is going to be allowed. So you can kind of take that out of your query, your SIM query, and then you can look for create VPCs that are coming from other principals. As I said in an earlier slide, the spreadsheet hell one, educated and empowered developers are key. Always have a conversation with your builder. If you see something that might impact them, ask, hey, why are you doing this? Is there a reason that you're doing it this way?
So if you combine like what I showed on in that little AI demo where I'm just going to see who has those permissions in the first place, that's going to give me a rough cut. And then Chris is here where you actually look at the real activity in that environment and do that evaluation. So there's extra steps you have to go through with this. Yeah. You use your SIM, you can use Access Analyzer, you can do it by pulling out a CloudTrail yourself and running Athena queries. Mm-hmm. That's really going to help you reduce the odds that you're going to break something.
Yep. And then maintenance, again, infrastructure is code, please. Store them in a way that is reproducible. Invariants should be well communicated. Never surprise a builder with, I was following this Medium blog post or this blog post from Jeff Barr, and I suddenly couldn't do something. Well, let the developers know what's allowed and what's not. One of the first things I'll do in any organization is create a cloud security baseline that's like, this is what good looks like, this is what you're allowed to do, this is what you're not allowed to do, or this is what certain teams are empowered to own and maintain. And again, GitHub internal repos, that concept is really good for this. Be transparent with what the guardrails are. Understanding the trust boundaries of your pipeline. So these are really important security controls. And if you delegate the deployment of them to GitHub, which is maybe not managed by the central cloud team, which is maybe got third parties involved, you've changed where the trust boundary is. If I just did it all ClickOps, I had to be an administrator, have organizations full admin in the pair to be able to make this change. But if I build a pipeline using GitHub Actions, then I just need to be able to merge to main on that repo to change things in the organizational management account. So you really want to be careful and think about who can actually make a change to AWS organizations once you put together this pipeline. I like leveraging the native code pipeline, code build tools. So I treat everything coming out of GitHub as untrusted user input. And I'll review the PR, and then I'll say, go ahead and plan. And then I'll review the plan to say, okay, this is what I expect to happen. And then I will approve the plan for the apply to happen. So it's a lot of manual human steps but I don't trust what's happening in GitHub because more people have access to GitHub than have access to my organizational management account. I guess, yeah, organizational hierarchy. So this is sort of, I think, one of the AWS best practice diagrams, and you'll see there's an exceptions OU on there.
No, I wrote this one.
Oh, you wrote this one? Okay, well.
This is Cloud's Law.
Very good. I hate the exceptions OU.
I like it.
Because invariants shouldn't have exceptions. If you don't want a specific service control policy to apply to an account, have a different workload account, or write your invariant such that it doesn't. You should never have to move an account from your production OU, your workload production OU, into an exception OU to do something. Because you're not just turning off the invariant and the control for what you need to fix, you're turning off all the controls. All of the invariants, all of the protections that are applied at the workloads OU go away when you move it to the exceptions OU.
Now, Chris and I agree on a lot of things in life. One of them is that Rebels is the best part of Star Wars, but the TV show Rebels?
Yes, yeah, no, I'm confirming that, yeah.
Yeah, he's confirming that one. We disagree a bit on the exceptions OU. I do tend to build in an exceptions OU that has none of my invariants, none of my service control policies or anything on it. I might use that for incident response. I might use that for some it's a temporary holding tank for when, oh no, I really need to figure something out now. I just want to have that there. But the ability to move your accounts between OUs does need to be super restrictive because you don't want somebody to use it. So nothing permanent in the way I use the exceptions OU. There's never anything permanent in there. It's a temporary holding tank, and I should probably change the name because it is misinterpreted as being everything with all of its exceptions and its custom policies goes here. That's not how I use it. That's the one I dump things into that have no policies on them at all.
Onboarding OU is another important one. So everybody goes through mergers and acquisitions, and you're going to buy a company and they're going to have a bunch of AWS accounts, and you're going to need to add them to your organization so they get your new discount. But you probably don't want to, 3 days after the acquisition, when you don't really know what the tech stack is, just drop all your invariants on that poor unsuspecting company. So I create an onboarding OU, and actually I create an onboarding OU and then another OU underneath that for the actual acquisition. So I can have multiple acquisitions going on at once. I bring them into my environment. They'll immediately start recording CloudTrail. They'll immediately get my guard duty detections and everything else. But I don't start enforcing my invariants on them until I understand what the implication is. So again, it goes back to now before I can move them out of the onboarding OU into a new workloads OU, I've got to do the same thing that we talked about earlier. Go into the SIM, look at what actions are happening, understand, am I going to break this new acquisition by applying all of my security controls to them right away? So an onboarding OU.
Oops.
The nursery OU is kind of for AWS accounts that are just getting born. And you might not have service control policies on that, like the one that prevents turning on block public access, because you actually need to enable block public access at account birth. So as part of the account lifecycle, you drop it in the nursery OU, nobody has access to it, you put in all your declarative controls, and then you move it into the workloads OU, and suddenly nobody can alter those controls. Suspended OU is kind of for the end of the account lifecycle. You're going to shut something down. I always drop a deny everything on that suspended OU. And that allows me to say, oh, hey, we moved into the suspended OU and something broke. Let's move it back and figure out what happened. Because if I just close the account, it's a lot harder to recover because I have to open a support ticket and get them to re-enable the thing and everything else. But if I'm just denying everything, I'm going to know if there's an S3 bucket somewhere that is needed or something like that.
This is where you can find us. We've run right out of time here. Chris and I are both available. We're also involved in the Forward CloudSec Slack community and some other places. And thank you for your time today.
Yep. Please complete the session survey in the app. And
all right. Thanks,
thank
everyone.
you.